Alright, discrete random variables, day 2. Problem number 1. Let x be a random variable that represents the number of questions that students guessed correctly on a quiz with 3 true-false questions. Alright. So, list all possible outcomes for x. So remember, x is the number of questions that students guessed correctly. Okay, well, if there were 3 questions, then the possible outcomes for x are maybe they guessed none correctly, or maybe they guessed 1, 2, or 3 correctly. So these are the possible outcomes for x based on what they said. Now, the probability distribution for x. So that means we make the table. Okay, so we'll put the possible values for x first. So that's 0, and 1, and 2, and 3. Now, down here we will put the probability of each one of these things. Alright, but if we want to know the probabilities of each one of these possibilities, each one of these x values, we need to know a little bit more. We need to know what all the outcomes are. So, when you first take a look at it, you see that it says true, false questions. So you might be tempted to set up a diagram of true and false. But you have to look carefully. X doesn't have anything to do with the number of true or the number of false. X is a random variable that represents the number of questions that the students guessed correctly. Okay? So x is a number correct. So we need to have outcomes that involved correctness. So in other words, there are 3 questions here. Okay? 3 true-false questions. If you're guessing, you're either going to get the question correct or incorrect. So, based on this word right here in yellow, those are the 2 choices we're going to put on our tree. So, when it comes to the first question, you guess. Either you get it correct, C, or you get it incorrect. Okay, those are the 2 choices. Okay, so that's, let's say question number 1. Then comes question number 2. On question number 2, well, first of all, let's say you got question number 1 correct. Well, then, now question number 2, you're either going to get correct or incorrect. Alright, but maybe you got question number 1 wrong. Incorrect. So then still the choices for question number 2 are correct or incorrect. Okay, so far the possibilities are you got question 1 correct and you got question 2 correct, or you got question 1 correct and you got question 2 incorrect, or you got question 1 incorrect and you got question 2 correct, or you got question 1 incorrect and you got question 2 incorrect. So at this stage we have 4 possibilities. And that brings us to question number 3. Okay? Alright, let's say if we got, say if we took this path. Once we get to this point, from here, question number 3 will either be correct or incorrect. Or if we took this route, from here, either question number 3 will be correct or incorrect. Okay, or same thing from here. So in terms of, the way you create the chart, you take each answer and then you split it up with the possibilities. So if this one was correct and we're here, then from there you could either go correct or incorrect. Alright, each one gets split up into correct and incorrect. Alright, there were only 3 questions, so this represents question number 1, question number 2, and question number 3. Alright, so this shows us how many possibilities there are. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And let's see, let me flip this around. Okay, and talk about those 8 possibilities. So this is 1, 2, 3, 4, 5, 6, 7, and 8. Alright, now let's break this down. Okay, so outcome number 1 is like this. If you got the first question, second question, and the third question correct. So that's C, C, C. Okay, I'll do it like this. 2, 3, 4, and then we'll do 5, 6, 7, and 8. Okay. Alright. Outcome number 2 is this one right here. Okay, that's outcome number 2. Alright, so that's the one where you get the first one correct, and the second correct, and the third one incorrect. Okay, picking up the speed a little bit. This one is correct, incorrect, correct. Okay, the fourth one is correct, incorrect, incorrect. The fifth one is incorrect, correct, correct. The sixth one is incorrect, correct, incorrect. The seventh one is incorrect, incorrect, correct. And the eighth one is incorrect, incorrect, incorrect. Okay, these are the 8 possible outcomes in terms of which ones you get right and which ones you get wrong. Okay, now in red I'm going to record the x value of each one of these, because remember, x is the number of questions that you guess correctly. So in outcome number 1 you get 3 correct. Outcome number 2, you have 2. Outcome number 3, you have 2 correct. Outcome number 4, you have 1. Outcome number 5, 2 correct. Here you have 1 correct, 1 correct, and 0 correct. Okay, so these reds are my x values, the x values of each outcome. So if I want the probability of getting 0 correct in this situation, I need to look and see how many times 0 occurred. Well, 0 occurred 1 out of 8 times. Okay, 1 out of 8, I do believe, is 1.25. Okay, I'm sorry, 0.125 is what I meant. Okay, the probability of getting 1 correct. Well, that happened 3 times, 3 out of 8 times. Okay, that's 0.375. Okay, probability of getting 2 correct. Well, that happened again 3 out of 8 times. 0.375. And the probability of getting all 3 correct. Well, that happened only once. 1 out of 8 times, and again that is 0.125. Okay, these are the probabilities. Every time you create a probability distribution, you should check and make sure it all adds up to 1. Alright, in this case, just add up the numerators. Okay, 3 plus 3 is 6, 7, 8. So that's 8/8, which we know is 1. Alright, so there it is. Here's our probability distribution. Alright, now constructing a probability histogram. The biggest number on here is 0.375. So right around here, I'm just going to go ahead and go to 0.400. You know, think of this as 375. So that would make this 0.100, 0.200, and 0.300. See how it helps to make them all the same number of decimal places? In this case, 3 decimals. Easy comparison. So the first bar of our histogram is going to 0.125. So that's just a little bit over 0.100. So right about here. Okay, and then 0.375. So that's right about here. And then another 0.375, so I'll just go straight across. And then another 0.125. So there's our histogram. Of course, this is symmetric. Alright, because it's got the balance thing happening. Alright. Oh, I forgot to put the numbers down here. Yeah, this was 0, 1, 2, 3. By the way. Okay, D. Find the mean and the standard deviation for the number of questions that students guessed correctly. Alright? So we're going to find the mean and the standard deviation from our probability distribution. We learned that the mean, the formula for it is the sum of all the xp's. Alright, so we're going to do x times p, and we're going to add them all up. So that means I could do 0 times. Now, it doesn't matter if you use the decimal form as long as you didn't round, or the fraction form. In class I did the decimals, so I'm going to do the fractions this time just to show that it doesn't matter. So x times p, so 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. Alright, so this is xp plus xp plus xp plus xp. And that is how you calculate the mean from a probability distribution. Of course, 0 times anything is 0. Okay, so you can just cross that out. And just go ahead and do the rest. Okay, so let's just add these up, guys. So I'm doing 1 times 3/8. Okay, plus 2 times 3/8 plus 3 times 1/8. And there you go. 3/2 is the mean, or in decimal form, 1.5. Whoa, I missed. Okay, so the mean is 3/2, or 1.5. Okay, so that's the mean. Now, how do we find the standard deviation? Now, the standard deviation, actually, first we have to start by finding the variance. Once we find that, then we'll just take the square root of it, and that'll give us the standard deviation. The formula is we need to do the sum of the x's minus the mean squared times the probabilities. You just need to memorize this little formula. Alright? So, here again, so the x's minus the mean. So, 0, so, you know, these are the x's, 0, 1, 2, 3, okay? So, just like right here, 0, 1, 2, 3. So, but this time I'm doing the x value minus the mean. The mean is the 1.5 that we just found. So, 0 minus 1.5 squared. And remember the probabilities, we can just use them again. So 1/8. Maybe I should have done 3/2. You know, if I'm going to do fractions, I'll stick with fractions. It really doesn't matter, is the real point. So this is 3/2. So that's going to be plus 1 minus 3/2 squared. Alright, it's always the x minus the mean, and the mean is going to stay 3/2. Anyway, times the probability, which is 3/8. Okay, plus 2 minus 3/2 squared times 3/8. Okay, plus, let's see if I can squeeze this in here. You know what, I think I'll just go ahead and wrap it around. Never mind squeezing it in. Okay, I'll just wrap it around. So, plus, the last one is going to be 3 minus 3/2 squared times the probability, which was 1/8. Okay, so if I add all of this up, that should give me the variance. So let's go ahead and do that. Okay, so that was 0 minus 3/2 squared times 1/8 plus 1 minus 3/2 squared times 3/8. Okay, plus 2 minus 3/2 squared times 3/8 and one more, plus 3 minus 3/2 squared times 1/8. Okay, 3/4 is the variance. Okay, so that tells me that the variance is 3/4. Okay, also known as 0.75. Alright, so this is technically the variance. Now, so if you want the standard deviation, we need to unsquare this. In other words, we need to use the square root. Okay, and it doesn't matter whether you're doing the fraction form or the decimal form, but you need to take the square root. So I'll just use the fraction since we had it before. So square root of 3/4. Okay, so 0.866. That is your standard deviation. Whoops, I said 866. Okay, and that is how you find the mean and the standard deviation. Alright, let's take a look at problem number 2. Alright, looks like problem number 2 refers to a problem from last night's homework, and I didn't actually make a video of that, so I think I need to actually go back and do number 1 from last night's homework, so stand by. Okay, so a couple plans to have 3 children. There are 8 possible arrangement of girls and boys. For example, GGB means that the first 2 children are girls and the third is a boy. Okay, fine. All 8 arrangements are approximately equally likely. Write down all 8 arrangements of the sexes of 3 boys. I'm sorry, the 3 children. What is the probability of any one of these arrangements? Okay, so 3 children are coming, but the first child, there are only 2 possibilities. It's either going to be a boy or a girl. Let me zoom in. Okay, as I was saying before I was so rudely interrupted. Okay, so from there, say if you had a boy, then the second child could either be a boy or a girl. Say if the first child was a girl, the second child either going to be a boy or a girl. Alright, picking up from there, okay, so we have our first child and we have our second child possibilities, and now we need our third child possibilities. And of course, to get our third child possibilities, all we really need to do is take each one of these and again split them up, because you could either go boy or girl in each case. BG. Okay, so when they say there are 8 possibilities, these are the 8 possibilities that they're talking about. Okay, and I'm just going to squeeze them all in down here. So one of them is boy, boy, boy. Alright, 3 boys in a row. Yay! Second one is boy, boy, girl. Okay, the third one is boy, girl, boy. Alright, the third one is, the fourth one is boy, girl, girl. Okay, the fifth one is girl, boy, boy. I should have put it over here. Girl, boy, boy. Brat. Okay, and then we have girl, boy, girl. Okay, and then this one is girl, girl, boy. And the last one is girl, girl, girl. Alright, in the end I decided to write these horizontally. Makes me wish I had done that the whole time, so I'm gonna go back and fix that. Okay, so I guess that's it for part A. Just write down all 8 arrangements. 1, 2, 3, 4, 5, 6, 7, 8. There they are. What now? Let X be the number of girls the couple has. What is the probability that X is 2? Okay, if X is the number of girls, then let's see what's what. Well, the first outcome has 0 girls. The second one, 1 girl, 1 girl, 2 girls, 1 girl, 2 girls, 2 girls, 3 girls. Okay, so these are the possible X values. Alright, so the probability of having 2 girls. Okay? In other words, the probability that x is equal to 2. Well, let's see. How many times were there 2 girls? 1, 2, 3. So that's 3 out of 8, alright? Because there's a total of 8 possibilities. So we have 3 chances in 8. So 3/8 is the probability. Or as a decimal, that would be 0.125. Okay, now give the probability distribution. Okay, alright, this pen is too thin. Let me kick it up a notch. So the probability distribution, my friends, is this. We have x, and then we have the probability of x. Alright, the possible number of girls, you could either have 0 girls, or 1 girls, or 2 girls, or 3 girls. Okay, the probability of having no girls, that only happened 1 time in 8. Okay, so that's 1/8, that's 0.125. Yeah. Wait, but then I said this was, I messed up when I said this was 0.125. I was thinking of 1/8. I'm tired. 3/8, I don't actually have that memorized, so let me use my calculator. 0.375, of course. That's the answer, part B. Anyway, okay, the probability of having 1 girl, that happened 1, 2, 3 times. So that probability is 3 out of 8, which we just saw was 0.375. Probability of having 2 girls, that happened 3 out of 8 times as well. Alright, these numbers show up an awful lot. I'm going to wind up memorizing them soon. And the probability of having all 3 girls, that only happened 1 time. So 1 out of 8. So back to 0.125. So this is our probability distribution, my friends. Okay, let me pause it there, because this is what we're supposed to use for problem number 2 of today's homework. So it says find the mean and the standard deviation for the number of girls the couple will have. So we're supposed to take this and come up with the mean and the standard deviation. So let me cheat, my friends. Cut and paste this mess. What now? You can't handle this. Okay, don't hate. You wish you had it. But you have paper and pencil. This looks much smaller now, all of a sudden. I'm going to make it a little bit bigger. Yeah, I'm going to make it bigger. Whoa, that didn't work out at all. Okay, so this is the probability distribution from last night's homework number 1. But we are now supposed to find the mean and the standard deviation. So the mean, okay, remember, is the sum of all the x times p's. Okay, so that means the mean is going to be, and I'm going to use a decimal this time, so x times p. So that's 0 times 0.125 plus 1 times 0.375. Okay, plus 2 times 0.375 plus 3 times 0.125. Okay, add up all of this and that will be my mean. Okay, so of course the one that has a fat 0 in it, I'm going to disregard it. Alright, 0 times anything is 0. So don't sweat that. So here I go. I'm just going to do the rest of it. Do I really need to put the 1 in front? No, I'm just going to do it so I don't lose anybody. So 1 times 0.375 plus 2 times 0.375 plus 3 times 0.125. Kabam! And there is the mean. Once again, look familiar? Didn't I just see that like on the last problem? It's weird. Okay, so the mean is 1.5. Okay, alright, if this is the same exact table, I'm gonna feel really silly. Okay, because if I find the standard deviation, why would they have us doing, it's the same problem again. Alright, it's kind of annoying. Yeah, it's the same exact distribution, so obviously we're gonna get the same answer. So if I wanted to find the standard deviation, I'm not going to sit here and calculate it all out again. It's just ridiculous. But I would do the variance squared. And oh look, I've done it. It's right here. The variance is the sum of the x's minus the mean squared times the probabilities. So that would look just like this. Okay, maybe I'll cut and paste it. Oh, so take a look. That's how you would calculate the variance, following the formula over and over again. X value minus the mean, which we just found, squared times the probability, and you just add all those up. Alright, that gives you the variance of 3/4 or 0.75. But for the standard deviation, you have to take the square root of it. So it's kind of weird because it was the same problem twice in a row, just with different words on it. But we're just going to pretend that didn't happen. Let's move on. Nothing to see here, folks. Number 3. Find the average grade and the standard deviation for the Statistics 101 course discussed in yes. What in the world is up with this homework referring back to other stuff that's not on the paper? Statistics 1, what? Alright, this was yesterday's notes. Okay, that the problem is referring to. And so example 1, see Statistics 101, this is the problem that they're referring to. So if you were absent yesterday and didn't get the notes or didn't have it worked out, then it's going to be extra hard for you to do this homework assignment. So I apologize because you know, I didn't write this homework assignment, and I wouldn't have anticipated a homework assignment that just constantly refers to other papers. No homework we've ever had has been like this before. No me gusta. I don't like it. But we're just going to deal with it. And hey, if you're watching this video, then hey, you're lucky because you can just look and see off of me. And so even if you didn't have it, you have it now because it's on your screen. Hey. Okay, so as you recall from the notes, example 1 was pretty easy to set up. They gave you the possible x values right there, 0, 1, 2, 3, and 4. And they gave you the percentages of each one. Remember, we're talking about this is A, this is B, this is C, this is D, and this is F. So they gave you the percentages. So there were 21% A's, so that's 0.21, and then 43% B's is 0.43, and then 0.30, 5% D, so that's 0.05, and 1% F, so that's 0.05. 0.01. Okay, so this is the probability distribution that we are working with. Okay, so I went ahead and cut and pasted the probability distribution into today's assignment where it should have been in the first place. Anyways, let me stop venting. Let's go ahead and calculate the mean. Alright, remember the mean is the sum of all the xp's. So that means I need to do 0 times 0.01 plus 1 times 0.05 plus 2 times 0.30 plus 3 times 0.43 plus 4 times 0.21. Alright, put all that in your calculator and you will have the mean. I'm going to do that off camera. Alright, I got a mean of 2.78. Alright guys, just for fun, I'm going to do this on the calculator using the table feature. So, I mean, for a problem this short, it's just as easy to do it by hand. Maybe even easier just to do it by hand, but I feel like you should know how to use the calculator, so here goes. If you type all the x values into list 1, that's what I've done. By the way, we started from hitting the data button. Then go to list 2, and that's where all your probabilities go. So 0.01, 0.05, 0.30, 0.43, and 0.21. Okay. Now, I want the sum of all the xp's. Alright, the xp's, the x's are in list 1, the p's are in list 2. So I need the third column to be list 1 times list 2. So just hit data again, go over to formula, hit enter. So this says L3 equals. If I hit data and L1, then I've got L1 so far. If I hit data and L2, now I have list 3 equals list 1 times list 2. Alright, so there's the product. These are all my xp's. Now I need the sum of all my xp's. So if I like to quit out of this first. So if I do second data, one variable statistics, make sure you're doing list 3. Okay, let me just blow this up for a second. Okay, if I scroll down to option number 5, then there's the sum, 3.23, which is not the same answer I had before. A little embarrassing. 3.23. Now I have to pause the video and figure out, did I make the mistake before or did I make a mistake now? Either way. Alright, I found my mistake, class. I could have gone back and edited the video and you never would have known that I made a mistake, but nobody got time for that. This right here, where I have the 0.5 for item number 1, it was not 0.5, alright? Somebody could have spoken up and let me know, but no, you let me do the whole video and have to go back and edit it. It was 0.05. Next time, let a brother know. So let's see, so this should be 0.05. Okay, that was the problem. There it was right there. So I'm sure that didn't mess you up at all. So if I do second stat, make sure it's L3. Okay, scroll down to item number 5 and 2.78. Okay, just like I got when I did it by hand. Alright, genius. Anyway, so that's the mean, 2.78. Now, the standard deviation. the standard deviation formula is, oh, sorry, this is variance actually. We'll have to take the square root in the end. But the formula for the variance is the sum of all the x's minus the mean squared, each one times its probability, and the sum over and over again like this. So that would be like this. It'd be like 0, sorry, it's not quite right. It would be like parentheses 0 minus, now the mean, we just found it, that's our 2.78. Okay, and then squared, and then times the probability, which is times 0.01. Okay, and then plus, and we would do 1 minus 2.78 squared times the probability 0.05 plus, now I'm just going to put dot dot dot. Okay, to shorten things up, if you want to, just show me the first two and then the last one. So there's the first two, and so I'm skipping to the last one, which would be 4 minus the mean of 2.78 squared times the probability of 0.21. So we could add all this up in your calculator. So remember, this is the variance. I am going to continue using the table feature, which is starting to grow on me. Okay, so using the table feature, I just need to change the list 3 formula. So if I hit data, go over to the formula area, hit enter. Alright, here's the formula that you're dealing with. But this is the formula for the mean. So let's just change it to be the formula for the variance, which is open parentheses. Now we want the x's. The x's are in list 1, so I'll hit data and list 1. Okay, and then it's supposed to be minus the mean. The mean was 2.78, close parentheses, squared. And then here we're supposed to do times each probability. Well, the probabilities are in list 2, so I'll hit data and I will choose list 2. So this is the proper formula for the variance. Okay, so if I hit enter, see if I can move this screen over here a little bit. Alright, so each one of these numbers, like this 0.0773, that is this right here. Okay, just so you understand, this is the 0.0773. Okay, so each one of these things that we're supposed to add is one of the numbers in this list. And of course, we are supposed to add them all up. Okay, that's what this means. But I can add them all up very easily if I quit my way out of this list by hitting second mode and then hit second data for the statistics menu. One variable statistics. Make sure you're on list 3. Hit enter a few times. Scroll down to item 5. Okay, so the variance is 0.7516. Okay, to get the standard deviation, I need to take the square root of both sides. Okay, so the standard deviation is going to be the square root of whatever this is. So square root of 0.7516. Okay, so square root of 0.7516. That is 0.8669. I'm going to round that to 0.867. That looks awfully familiar. Okay, so there is our standard deviation. Do you guys know what tedious means? Alright, well you do now. Tedious is this. Okay. Refer to last night's homework. Okay, I'm going to go back in time. Alright, never mind. Homework number 3. Find the mean and the number of rooms. Find the mean number of rooms for both types of housing unit. This is infuriating. Alright, so here I have cut and pasted the distribution from number 3 from last night's homework. So, we're supposed to find the mean for both of these. So, you know, this is the these are the x values up here, and these down here are the probabilities. Okay, so so let's start off with owned. So if I want to find the mean, you know what, I'll just use mean with a little o. That'll represent the mean of the owned units. Again, the mean is the sum of all the xp's. Okay, so that would be, if these are the x's, then xp, that's going to be 1 times 0.003 plus 2 times 0.002 plus dot dot dot, and then I'm going to skip to the end and put 10 times 0.035. Alright, this is how much work you need to show. Alright, you can show me the first 2 terms and then put dot 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 and then show me the last one. And if you want to do the rest in your calculator, that's fine, but you must show me this much work. Okay, now I'm going to definitely do the table feature on the calculator for this, no doubt. This is crazy. Let's see. Okay, hit your data button if you're going to do this like me. Hit your data button and clear out list. We'll clear out all the lists. If I hit data 1, okay, it didn't like that. Data 2, you know what? Okay, data 2, data 3. Alright, so hitting data and then the number, you can clear out those lists. Now, so list 1 needs to be all your x values, so that's just 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let me just scroll and double check. 5, 4, 3, 2, 1. Okay, that's great. In list 2, this is where I'm going to put all of the probabilities. Okay, I'm going to type these in off camera, but it'll be like 0.003. Wait, I feel like I missed a decimal point. Let's see it. 0.003, 0.002, 0.023, and so on off camera. Okay, so there I've typed in all my probabilities for list 2. Then in list 3, here's where I do the formula. I need to do the sum of all my x's times p's. So I will hit data, arrow over to formula, hit enter to add a formula. Alright, so it's asking what do I want L3 to be? Well, I want x's times p's, so that's list 1 times list 2. So I'll hit data and then list 1 and then data and list 2. So list 3 will now be list 1 times list 2. In other words, the x's times the p's, because that's the mean. So if I hit enter, okay, these are all the xp's. X times p, x times p, x times p. Now we need the sum of all the xp's. So I like to quit out of this first. And then second data, one variable statistics. Make sure it's list 3, enter, 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 and scroll down to item number 5. That's the sum. So 6.284, that's the mean of the owned units. Okay, so now let's do the mean of the rented units. Again, I'm going to just show the first two and then skip to the last one. So this would be 1 times 0.008. Okay, I'm looking at these probabilities now. Plus 2 times 0.027 plus dot 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 plus 10 times 0.003. Okay. Now let's find that mean. So back to the data. The x's are fine, but I'm going to have to change the probabilities to be these. Let's see, can I clear this out? Formula error. Okay, yeah, I didn't like that. Okay, alright. Forget about it. You know, I'll just clear this for now too. Okay, so list 2. I'm just going to type in all of the probabilities in list 2 just like before, but now I'm using the 0.008 and the 0.027. Okay, and so on off camera. Okay, so here I've typed in all the probabilities. Okay, and let me just double check our formula. So hit data, let's check the formula. Okay, so list 3 needs to be, I'm still doing the mean, so x's times p's, so list 1 times list 2. So let's see, data, list 1, data, list 2. Okay, so if I hit enter, then these should be all the xp's. And once again, I need the sum of all of them. So I will do, first I will quit out of this, and I will do second data, one variable statistics, make sure we're doing list 3. Alright, scroll down to item 5. Because that's the sum. So 4.187. Okay, and that is the mean for the rent of the rented units. Okay, mean number of rooms for both types of housing units. Okay, there you go. Okay, this homework is interminable. Look it up. Find the standard deviations for both. Oh, okay, so now we're supposed to find the standard deviations for these same things. Okay, I wish they would have said that before I deleted all the probabilities from the other problem. It's an obnoxious assignment. Any hoozle. Standard deviation. So first we need the variance. Okay, because I already have the probabilities from the rented ones in there, I'm going to do that first. So the formula for standard deviation, well, for variance, is we're supposed to do the sum of all the x's minus the mean squared times the probability. So I'm just going to show a couple of those. So in this case, that would be 1 minus, and the mean here is 4.187 squared, and that first probability is 0.008, and then plus 2 minus the mean squared times its probability of 0.027 plus dot dot dot, and skip to the last one, which will be 10 minus the mean 4.187 squared times its probability of 0.003. Okay, and like I said, looking at the data button, this is already in the calculator. I just need to change the formula in list 3. So if I get over to list 3, hit data, edit the formula. Okay, so right now my formula is saying list 1 times list 2. So I'm just going to clear that out and put the the variance formula, which is x's, right, data list 1, because that's where my x's are, minus the mean, which is 2 point something, but I forgot, so I gotta check. The mean was, did I say 2 point something? I meant 4.187. That's why I had to check. Okay, so the x's minus the mean squared times the probabilities, which are in list 2. So I need list 2 now. So data list 2. So there's your formula. So if I hit enter now, all of these values are my little variance formulas. But of course we're supposed to add them all up. So I will quit my way out of this first and then hit second data, one variable statistics, make sure you're on list 3, hit enter a few times, scroll down to item number 5. So 1.71. Okay, so that is the variance of the rental units. Okay, 1.71. Okay, now we're supposed to find the standard deviation though, not just the variance. So to find the standard deviation, I need to take the square root of this. So square root, square root. So the square root of 1.71 is 1.31. Alright, so that is the standard deviation of the rental units. Okay, and we're also supposed to find the standard deviation of the owned units, which is the same procedure, okay, using that same formula. So it's going to be 1 minus 4.187 squared times the probability there, 0.003, plus 2 minus 4.187 squared times its probability of 0.002 plus ... Skip to the last one. 10 minus 4.187 squared times its probability 0.035. Okay, that's how you find the variance there. Going back to the calculator, but I have to go back one more time and put the probabilities back in that were just in there before, but I erased them because I didn't know I was going to have to come back to it. I'm trying to say is boo. It might be best just to type over the probabilities. If you try to clear the list, causes different kinds of errors. So I might recommend, so this first probability is 0.003, for example, 0.003, you know, just type right over it, 0.002, okay, and so on off camera. Alright, I just changed all the probabilities back to being the probabilities for the owned units. The good news is we don't even have to change the formula for list 3. Okay, it still has the correct formula in there from the last step. So just quit your way out of this and do second data, one variable statistics. Make sure it's still on list 3. Okay, enter, enter, enter. Scroll down to item 5 and there is your variance, 7.09, let's say. Okay, so our variance is 7.09. So to find the standard deviation of the owned unit, we have to do the square root of both sides. Okay, so the square root of 7.09. Alright, so that's 2.66. Alright, and there is your standard deviation. So, we found the standard deviation for both types of unit. Oh my goodness, did we actually get to the end of that homework assignment? I didn't think I was going to survive it. Alright, yeah, that was over an hour, so that's awesome. Alright guys, I hope this was helpful. I hope I didn't waste 3 hours of my life just now making this video. I will see you on the next video.